look at the quadratic formula and the discriminant. Now, we've done a lot of different ways on how to solve quadratic equations. Now, remember, a quadratic equation has the form of ax squared plus bx plus c, in which a is not 0. So the highest power you're going to have is that x squared. Now, graphing is one way we started with in this chapter. You can use that sometimes. An exact answer, or if you're just trying to figure out if it's a reasonable solution, not always exact. Factoring is another way. That's probably the one that we're most comfortable with. If you have the constant term as a 0, like something like this, it's easy to factor. Or if the factors are very reasonable, easily to work with. Now, in the last lesson, we did completing the square. And it's useful. We can always use completing the square. Sometimes it's a little bit more difficult. If b is even, then completing the square is easy. If b is an odd number, sometimes that's not as easy, but still doable. You're just working with fractions. Today, we're going to look at quadratic formula. You can always use a quadratic formula. You can use it for any problem. It's useful when other methods fail or are too tedious. So even something with a decimal, which would not be easy at all with any of the other methods, quadratic formula will be the easiest. Okay, so what is a quadratic formula? You will see on YouTube, there are a lot of different ways that people remember the quadratic formula. There's a song that goes Pop Goes the Weasel that people sing it to. Don't worry, I'm not singing the quadratic formula to you today. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, things that students forget. Just remember that 2a in the denominator has to be there. Also, this b squared minus 4ac is the radicand. All of that is underneath the radical sign. All right, so let's try it. Number one, again, it has to be in standard form, which this one is. And let's first identify the a, b, and c. So a is 2, b is 6, and c is negative 7. Okay, so let's start with x equals negative b, which is negative 6, plus or minus the square root of 6 squared minus 4 times a, which is 2, and c, which is 7. Negative 7, all over 2 times a, which is 2. So that gives me negative 6 plus or minus the square root of 6 squared is 36. Now, because this b squared here in the formula, this number right here, hugging the radical sign, is always going to be positive. So that's one thing you want to be careful of. Now, I think the easiest way to do the next part is just to worry about the signs. I have a negative and a plus and a negative. So when I multiply those together, I'm going to get a positive. And then worry about the numbers. 4 times 2 is 8. 8 times 7 is 56. That way you're not, concerned about, do I use the negative twice, or did I do it enough, or is it negative 4, or is it times negative 4? So I just feel like that's the easiest way for students. All over 2 times 2, which is 4. All right, so now we have to clean it up. Negative 6 plus or minus the square root. This gives me 92 all over 4. Okay, so we have negative 6 plus or minus the square root of 92 has a perfect square of 4 that goes into it, 4 and 23 all over 4, which is negative 6 plus or minus 2 root 23 all over 4. Now, again, we have to see if we can simplify. So I can factor out a 2. And I like to do this at first instead of trying to do it in your head, just so that way you're not forgetting. 2 times negative 3 gives me negative 6. I'm going to factor out the 2 there. And then my bottom is really 2 times 2, which is 4. Okay, so I can simplify my 2's. So my final answer is negative 3 plus or minus the square root of 23 all over 2. Okay, that's actually where it would, if you were to graph it, that's where it's going to touch the x-axis. Now, in our next problem, we don't have it quite in standard form yet, so we need to add 10 to both sides. And I have x squared minus 6x plus 10 is equal to 0. So a is equal to 1, b is equal to negative 6, c is equal to 10. So x is equal to negative base. So we have a negative 6 is our base. So it's minus a negative b is going to be a positive 6 there, plus or minus negative 6 squared minus 4 times a, which is 1, and c, which is 2, all over 2a, which is 2 times 1. So that gives us 6 plus or minus the square root. Like I said in the last problem, this first number hugging that radical sign is always going to be positive. So negative 6 squared, remember, is negative 6 times negative 6, which is positive 36. You're going to use your calculator, make sure you have those parentheses around it. Negative 4 times 1 times 10. Negative times positive gives us a negative. And then we have 4 times 1 times 10 is 40 all over 2. So that gives us 6 plus or minus the square root of negative 4 over 2. I don't know why I put 20 up there, 2a. So that gives us 6 plus or minus. Remember that square root of negative 1 is equal to I. So that gives us 2i all over 2. Now again, we'll factor out what we can. So we can factor out a 2. And that gives me 3 plus or minus I all over 2 in the bottom. My 2's will simplify. So my final answer is 3 plus or minus I. All right, let's look at the discriminant, which is next. The discriminant tells us a lot of information. The discriminant is the information underneath the radical sign, right? The radicand underneath the radical sign. The value of the discriminant can be used to determine the number of solutions or roots of a quadratic equation. That's really what you use it for. Okay, so we have a couple scenarios. This table is great to help you, especially when you're getting started. So think about this. We have the square root of b squared minus 4ac. That's the radicand, right? So b squared minus 4ac is the discriminant. So if the number underneath there is positive, square root of 11, square root of 10, whatever it is, if it's greater than 0, positive, we have two options. If it's a perfect square, then we know, first of all, we know regardless whether it's a perfect square or not, we know if it's positive, it's going to hit, because you're going to remember, you're going to have that plus or minus in front of it. So you're going to have two solutions, meaning it's going to touch the x-axis twice. Okay, if we have a perfect square, remember perfect squares are rational numbers. So we're going to have two rational roots that are real. If it's not a perfect square, square root of 11, square root of 12, we're going to have two real irrational roots. Now, if underneath, think about this, if underneath here is 0, you're not going to have plus or minus 0. That's not going to work. There's just only one answer. Plus, the square root of 0 is 0, right? So you're only going to have one solution, right? Whereas before you had that plus or minus with a positive number, you're going to have two solutions. That means that it's only going to touch that radical sign it's only going to touch that x-axis one time, whether it opens up or down. So you're going to have one real rational root. Now, if the radical sign underneath, if the information underneath the radical sign, the discriminant, is negative, such as like negative 11, it means it's not going to touch that axis because it's complex root or it's an irrational, imaginary root, right? So that means it's never going to touch that x-axis. Okay? It could be plus or minus negative 11. It could be plus or minus negative 16. It doesn't matter. If you have if that radicand is negative, then it's going to be an imaginary root. Okay? So again, it'll touch, you'll have two of those. All right, so let's practice some. We're going to go back to this table that again is going to help us. So you're going to find the discriminant, and then you're going to describe the number and type of roots, okay? So again, I need my a, b, and c. It's all set to 0. So a is equal to 7, b is equal to negative 11, c is equal to 5. So again, I'm going to write this up here, b squared minus 4ac to help you. So I have negative 11 squared minus 4 times a, which is 7, and c, which is 5. So that gives me 121. And again, I can use my calculator if I want. Negative times positive gives me a negative. 4 times 7 is 28 times 5 gives me 140. So I'm going to have negative 19. So that's the discriminant. Okay, so we have a negative answer. So let's go back to our chart. Negative, remember, means we have two complex roots. So that's what we're going to look at here. We also have two complex roots. That's the other part of that question. Two complex roots because our discriminant is negative. All right, let's keep going. I'm going to add 121 to both sides. Now we have x squared plus 22x plus 121 is equal to 0. So a is equal to 1, B is equal to 22, C is equal to 121. So our numbers are pretty big here. So B squared is 22 squared minus 4 times A, which is 1, and C, which is 121. Okay, 22 squared is 484. Minus times a plus gives me a minus. 4 times 1 times 121 is 484. So again, my discriminant is 0. Let's go back to the chart. Okay, so last time we had, it was negative, so it was 2 complex roots. This time where we have a 0, it means I have 1 real rational root. So that's going to be the other part of that question. It's going to be 1 real rational root. Okay, again, all of this is really understanding the quadratic equation and the graph. What it's going to look like. Okay, so again, here we go. Number 3, A is equal to -5, B is equal to 8, C is equal to -1. So B squared. So I have 8 squared minus 4 times A, which is -5, and C, which is -1. So this gives me 64. Negative times negative times negative gives me a negative. 4 times 5 times 1 gives me 20. So that's 44. That's my discriminant. Now that's positive, but this is not a perfect square. Not a perfect square. Okay, so let's go back to our chart. We need positive and not a perfect square. So let's go back, see what we have. So our first part here was positive. Not a perfect square is this one right here. So we have 2 real irrational roots. Okay, so it's going to touch the x-axis, but we have a rational answer there, solution. So I have 2 irrational roots. All right, let's take a look at our next one. So again, I'm going to bring that 7x to the other side so I can have it in standard form. And I have 15x squared minus 7x minus 4 is equal to 0. So A is equal to 15, B is equal to -7, and C is equal to -4. So B squared is -7 squared minus 4 times A, which is 15, and C, which is -4. So this gives me 49. Negative times positive times negative gives me a plus. 4 times 15 times 4 gives me 240. So 289, that is my discriminant. Now again, this is a perfect square. So we're going to go back to our chart one last time and take a look. So we have a positive answer, a perfect square. So we're going to have 2 real rational roots. Okay, so we'll say 2 real rational roots. Over here, I forgot to put the word real here, so we'll just kind of slide that in. Okay, so that's our lesson on discriminant and the quadratic formula to help us with quadratic equations. Okay, great job today. Have a good one.